Hi students, welcome back to this course, An Introduction to Mechanical Engineering. I am Professor Yao. Fluid Engineering. The contents, properties of fluids, pressure and buoyancy force, laminar and turbulent fluid flows, fluid flows in pipes, aerodynamics. Objective. The keywords. The application of fluid engineering to such devices, a diverse field as microfluids, aerodynamics, and medicine. The difference between a solid and a fluid. The physical meanings of a fluid's density and viscosity property. The characteristics of laminar and turbulent fluid flows. Reynolds number. Buoyancy, drag, and lift. The volumetric flow rate and the pressure drop of fluids flowing through pipes. Objective. At the end of this chapter, you will be able to recognize the application of fluids engineering to such diverse fields as microfluidics, aerodynamics, and medicine. Explain in technical terms the difference between a solid and a fluid. The physical meaning of fluid density and viscosity properties. Understand the characteristics of laminar and turbulent fluid flows. Calculate the dimensionless Reynolds number, which is most significant numerical value in fluid engineering. Determine the magnitude of the fluid force that are known as buoyancy, drag, and lift in certain applications. Analyze the volumetric flow rate and the pressure drop of fluids flowing through pipes. Summary. The keywords. Categorize substance, either solid or fluids. The principles of fluid engineering. Aerodynamics, biomedical engineering, microfluidics, and sport engineering. Pipes, hose, and ducts. The buoyancy force, drag and lift force, relative motion. Mechanical engineers categorize substance as being either solid or fluid, and the distinction between these two centers around how they respond to shear stresses. Mechanical engineers apply the principle of fluid engineering to applications such as aerodynamics, biomedical engineering, microfluidics, and sport engineering. The flow of fluids through pipes, hoses, and ducts is an example of this diversity. The buoyancy force develops when an object is immersed in a fluid, and it is related to the weight of the fluid that has been displaced. Drag and lift force develop when there is relative motion between a fluid and a solid object, and encompass situation when the fluid is stationary. and the object is moving. As in the case of automobile, the fluid is moving and the object is stationary, as in wind loaded on a building, or some combination of the two. Overview: fluid mechanics. The keyword: plays important roles: aerodynamics, biomedical engineering, piping system, microfluidics, and sport engineering. The principle of fluid statics: the pressure and buoyancy force of fluids. Ship, tanks, and dams. Hydrodynamics and aerodynamics. The motion of ocean and the atmosphere. Sophisticated computational models to simulate. Biomedical engineering. The lower wind resistance and improves the fuel economy of automobiles. Ski jumpers, racing cyclists, and marathon runners. The subject of fluid engineering plays important roles in the diverse application of aerodynamics, biomedical engineering, piping system, microfluidics, and sport engineering. Mechanical engineers apply the principles of fluid statics to calculate the pressure and the buoyant force of fluids acting on stationary objects, including ships, tanks, and dams. Fluid dynamics refers to the behavior of liquids or gases when they are moving or when an object is moving through an otherwise stationary fluid. Hydrodynamics and aerodynamics are the specializations focusing on the motion of water and air, which are common fluids that are encountered in engineering. Those fields encompass not only the design of high-speed vehicles, but also the motion of ocean and the atmospheres. Some engineers and scientists apply sophisticated computational models to simulate and understand interactions among the atmosphere, oceans, and global climates. Fluid mechanics also plays a central role in biomedical engineering, a field that was ranked as one of the mechanical engineering profession's top 10 achievements. Mechanical engineers sometimes apply sophisticated computer-aided engineering tools in order to lower wind resistance and improve the fuel economy of automobiles. In fact, those methods have been applied to design golf balls capable of long flight and help ski jumpers, racing cyclists, and marathon runners and other athletes improve performance. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz, and see you next time.